Hello YouTube. In this video we're going to look at matrix addition, and before we do this I basically want to comment on the nature of the operations with matrices. Often we add, subtract, multiply, and divide with things that are real numbers. What we're going to be doing here is we're going to be adding and multiplying with matrices, and I want to start with that. We say operations defined, operations that are defined. Let me rewrite that there. Are defined with matrix math. And there are only two operations that are defined with matrix math, and these are going to be addition, and I apologize for squeezing this in here, and multiplication. My handwriting is not that good. Multiplication. But basically, we're only going to be looking at addition and multiplication, and especially in this video, we're going to be talking about addition here. So let's go ahead and take a look at what we see with matrix addition. So we have two matrices here, A and B. And the first thing we want to comment on is the matrices can only be added if they have the same order. So that is to say that if A, this matrix A up here, had m rows and n columns, we could only add it to B if B also had exactly m rows and exactly n columns. So we say the sum of matrices with different orders is undefined. So if you ever had an instance where, you know, this was an m by n and maybe this was an n by q, you would just say, well, then you can't add those, it's undefined, okay? But only defined if we have two matrices of the same order being added together. And the nice thing about matrix addition is this. We say adding matrices by adding their corresponding entries is how you do it. So what we're going to basically say here is this. If you had two matrices A and B, I suppose you would say that matrix A has all of these entries in it that are in the ith row and the jth column of their particular matrix. And if we were to add it to the matrix that was populated with all of these little b things here that are also in the ith row, jth column, we say that their sum is defined simply by this. We say it is the matrix contained with all of the entries where what you did was you added the ith row A thing that was in the ith row, jth column to the B thing that was in the same spot, basically, and you get some new thing that is also in that spot. So looking at this example down here, I want to find A plus B, and I have two matrices here that are both 3 by 3 matrices. We have 3 rows, 3 columns in each one. So what we're going to get here is basically this. When we say find A plus B, I'm going to go ahead and write this right now. I know that we're going to get a 3 by 3 matrix because we could say that it's defined if we add two matrices with the same orders, and you'll just get a new matrix with the same order. And in order to find this 3 row, 3 column thing, basically to get this, say for instance, first row, first column entry in this new matrix, we would add the first row, first column entry in each of the previous matrices that are being added together. So we say 2 plus 2 would be 4. And we could just straight up do this for all of these entries here. We would say this 2 that's in the first row, second column, plus this 0 in the first row, second column would be 2. So I'm going to move a little bit more quickly here. Basically, 4 plus 0, we would get 4. Negative 3 plus this 1 would be a negative 2. This 0 plus a negative 4, of course, would be negative 4. Negative 1 plus a positive 3 is just a 2. This positive 2 plus a negative 1 is a 1. 1 plus a 3 is a 4. And then last but not least, 2 plus a 2, that would be a 4. Okay, so we get this new A plus B, and basically it would be this matrix right here. This would be the sum of the two matrices. And so what I want to talk about now is what about subtraction? Well, what I'm going to say is this. Looking back up here, I said that the only two operations defined with matrices are addition and multiplication. So we're going to do this. We're going to say always, I'm going to try handwriting again here. Always rewrite differences as sums. Differences as sums. And so what I basically mean is this. We're going to rewrite this A minus B as A plus a negative 1 times B. So one of our other operations that I guess I didn't list here, I looked at the two major ones. We have scalar multiplication as well that we'll look at in one of these videos. We'll say that we could just take A and add on the negative of B here. And so in this particular instance, we're just going to look at it this way. We're going to say A, which would be 2, 2, 4, negative 3, 0, negative 1, and 2, 1, and 2. We're going to take this, and instead of subtracting off B like this, we're going to say 2, 0, 0, 1, negative 4, 3, negative 1, 3, and 2. What we're going to do is we're going to interpret this as addition of a negative 1 times all of this stuff right here. And so basically, if we were to scalar multiply this whole matrix by a negative 1, sorry to spoil the surprise with scalar multiplication, but basically we could distribute this throughout and it would become positive, and everything in here would change its sign. So 2 would become negative, the zeros are still neutral, this would become negative, this would become positive, this would be negative, 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 and this would become positive. So when we add these two new matrices, what we would get now is 2 plus a negative 2, which is 0. 2 plus 0 is still 2, and 4 plus 0 is still 4. Looking at the second row now, negative 3 and a negative 1 is a negative 4. 0 and a 4 is, of course, a 4, and 1 and a negative 3 is a negative 4. Last, we would say 2 plus a 1 here is a 3, 1 plus a negative 3 is a negative 2, and 2 plus a negative 2 is a 0. So this would be the difference of the two matrices here, A minus B, and I did my work down here. But basically, one question I want to answer right now is this. Even though I say you must rewrite this as adding the opposite of B because only addition is defined, what I want everybody to see here is this. If we would have just taken 2 minus 2, you still would have gotten 0 here. And if we would have taken this 2 minus this 0, we would have gotten a 2 here. So can you interpret this as subtraction from left to right? You know, this 2 minus this negative 1. Well, that's technically 2 minus a negative 1, which was 2 plus a positive 1 and get a 3. Yes, you can do it that way, but it's safer to go ahead and rewrite this as adding the opposite. Okay. So the last thing I want to do in this video is take a look at, could I have done this on a calculator, A plus B? And so what I want everybody to see here is this. I've already went ahead and I typed in matrix A right here, and I'll just go ahead and show you this. If I hit enter on A, here's my matrix A. You can see I've got my 2, 2, 4, negative 3, 0, negative 1, dot, 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 dot. What I want to do is find A plus B in my calculator. So what I need to do is I need to put this in for matrix B. And on my calculator, I have a matrix button. On yours, you should see behind this x to the negative 1 key, probably. You have to hit second x to the negative 1. But we'll go into matrix, and remember to put in a matrix, we go to edit. And I'm going to edit matrix B here. So the first thing it asks me is what are your number of rows and number of columns respectively. So I say 3 by 3, and then I'm going to go ahead and put this in. Now I'll tell you what, in my experience, if you've got a calculator by hand and you have a paper next to you, put your calculator right next to your paper, right next to the system of equations or whatever it is you're working with, because you can type it in quickly. And if you're doing this on a computer, you can actually just hit the number key here, 2, 0, enter, 0, enter, and it'll type it in. So I can hit 1 enter here. The only annoying feature is that I actually have to hit negative 4 by clicking it in. Okay, so negative 4, enter, but then I have a 3, enter. We have a negative 1, got to click that one in. And then a 3, enter, and a 2, enter. So remember, when you're done with this, we always quit out of this menu. So I have my matrix A and my matrix B, and if I want to find A plus B, here's all we'll do. We'll just go back into our matrix menu and bring out A, and we're just going to hit plus, and then I'm going to go back in, and I'm going to find matrix B. Oops, I just need to hit my matrix button here. So we'll call out B. So A plus B, you notice that we get this 4, 2, 4, you know, this right here, we get the same thing that we got over here when we did it by hand. And if we were to do the subtraction now, if I had second enter, it'll bring up the last thing I typed in when you hit that second enter key. And I'll change this to subtraction, and I'll hit enter again, and you can see down here that we got the same matrix difference that we get on the calculator. So that's how you do matrix sums and differences, and how you do it on the calculator. Cheers.